Hi my friends and welcome back to the Repair and Installation TV channel. In the bustling port of Rotterdam, we witness an impressive engineering feat. Two of the world's largest crawler cranes working in tandem to load and unload massive components for wind turbines. This operation involves the CC 8800 with a capacity of 1,600 tons and the CC 6800 with a capacity of 1,250 tons. The cranes are essential for handling the enormous wind turbine transition pieces, TPs, and monopiles destined for offshore wind farms in the North Sea. These 480-ton wind turbine transition pieces have just arrived from Antwerp. Once they are offloaded from the barge, Saren's blue TP handler, mounted on self-propelled modular transporters, SPMTs, takes over. The TP handler is efficient and swift, capable of maneuvering these colossal pieces faster than a crawler crane. It transports the TPs to the laydown area, placing them gently on concrete foundation blocks. Next, the barge rotates to allow the cranes to reach the remaining TPs. The yellow transition pieces come from Antwerp, while the brown and white monopiles are manufactured locally in Rotterdam. Each transition piece will be paired with a corresponding monopile before being transported to the offshore wind farm. The cranes lift the monopiles in tandem, ensuring precision and safety. The monopiles, each weighing approximately 1,088 tons, are lifted using long slings attached to the crane hooks. This method prevents any metal contact that could damage the monopiles during the process. One by one, the remaining monopiles are carefully loaded onto the barge. This scene is part of an ongoing operation, with Sarens on site for several months, performing similar load-ins and load-outs. Once the monopiles are secured, it's time to load out the yellow transition pieces. The CC 8800 lifts the first TP, guided meticulously by the crew into the grillage. After all the pieces are on board and secured, they will embark on their journey to the North Sea, where they will play a crucial role in generating renewable energy. The development of heavy lift cranes has been transformative for the lifting industry, playing a crucial role in various sectors, including construction, maintenance, expansion, and decommissioning of industrial projects. The ability to lift large, heavy components efficiently and safely is critical to keeping projects on schedule and within budget. One of the leading companies in this field, Mammoet, exemplifies the capabilities and importance of heavy lift cranes. Mammoet operates the world's largest and most modern fleet of heavy lifting equipment, comprising over 1,000 cranes. These cranes range from versatile 10-ton all-terrain models to the formidable PTC and SK ranges, which can handle loads of up to 5,000 tons. The significance of these cranes becomes evident when considering their impact on industrial projects. Heavy lift cranes are indispensable in accelerating the critical path of construction and maintenance tasks. For instance, in the construction of large facilities or infrastructure projects, using heavy lift cranes allows for the lifting and placement of large modules in one piece. This reduces the time spent on site assembly, minimizes congestion, and leads to earlier project completion. As a result, facilities can come online sooner, enhancing their operational productivity and economic impact. In maintenance scenarios, the ability to replace key components swiftly is crucial for maximizing facility uptime. Efficient heavy lifting minimizes disruption, enabling multiple contractors to work concurrently and uninterrupted. This not only ensures the smooth operation of the facility but also supports the local economy by sustaining ongoing projects. Safety is paramount in heavy lifting operations. Engineered lifting plans are meticulously designed to protect personnel, the load, equipment, and adjacent structures. This focus on safety, combined with optimal project efficiency, ensures that heavy lifting projects are executed within the desired timeline and budget constraints. Mammoet's extensive range of cranes includes specialized models such as the LG 1750 crane with SX3 boom configuration, which is pivotal in constructing new generation wind turbines. Additionally, their large ring cranes offer enormous lifting capacity, long reach, flexible configuration, and quick mobilization. In just 8 months, Versabar accomplished a remarkable feat of engineering by conceptualizing, fabricating, testing, and deploying a groundbreaking underwater lift device known as the Claw. This innovative tool was born out of a specific need from offshore operators to enhance safety and efficiency during salvage operations, particularly to minimize diver exposure. The Claw comprises 2 identical grappling devices, each towering at 122 feet tall, 112 feet wide, and weighing an impressive 1,000 tons. These massive steel jaws are controlled by the VB-10,000 lift system, renowned for its robust capabilities in heavy lifting operations. Importantly, each claw operates independently, allowing for versatile maneuvering underwater. The primary objective of the claw is to retrieve topsides, large structures or components, lying on the seabed with minimal subsea preparation. This is achieved through its powerful jaws, which can individually grasp and lift substantial loads. For even larger objects, the claws can collaborate in a tandem lift, doubling their capacity and efficiency. To further streamline operations, custom-engineered baskets or cradles were developed to complement the claw. These cradles serve as stable bases positioned adjacent to sunken platforms. When the claw lifts a damaged topside from the seabed, it deposits it onto one of these cradles. This integrated approach ensures that the fragile topsides are securely supported throughout the ascent to the surface, minimizing additional stress and potential damage. The operational sequence begins with positioning the cradle near the targeted topside on the seabed. Once in position, the claw descends and carefully scoops up the topside, using its massive jaws. The topside is then securely placed onto the cradle. The Sleipnir, the world's largest crane heavy lift vessel, is a marvel of modern engineering, representing the pinnacle of heavy lifting capabilities and sustainable operation. Constructed in 2019 by Hirama, this semi-submersible crane vessel, SSCV, is equipped to handle structures weighing up to 20,000 metric tons. Sleipnir's impressive dimensions, 220 meters in length and 102 meters in width, are complemented by its dual cranes, each with a lifting capacity of 10,000 metric tons. A testament to its capabilities, Sleipnir played a crucial role in the Snorre expansion project, a significant increased oil recovery (IOR) initiative aimed at extending the Snorre field's productive life beyond 2040. This project, involving 24 new wells and substantial infrastructure additions, required the installation of a 600-ton module, which Sleipnir lifted quayside at Eibel in Haugesund in April. Sleipnir's sustainable features set it apart from other heavy lift vessels. It operates on liquefied natural gas, LNG, significantly reducing emissions. The vessel also incorporates a range of eco-friendly technologies, including LED lighting, a heat-cold energy recovery system, variable frequency drives, silicon-based anti-fouling paint, and the ability to connect to renewable shore power while docked in Rotterdam. Sleipnir has set multiple lifting records since its launch. In September 2019, it performed the world's heaviest lift by raising the Leviathan topside, weighing 15,300 metric tons. Mammoet Brazil has partnered with the consortium Techint Technip, CTTP-76, to integrate 20 modules onto the Petrobras P-76 floating production storage and offloading (FPSO) vessel. With the hull delivery date confirmed, Mammoet Brazil and CTTP-76 are set to promptly execute the project, with the module integration scheduled to begin in June or July. Mammoet will handle the weighing, transporting, and lifting of modules, which can weigh up to 1,935 tons. Michel Boudin, sales director at Mammoet Latin America, stated, "For this extreme heavy lifting task, Mammoet will mobilize its PTC-200DS ring crane, currently stationed in the USA. The PTC-200DS, of which we own 3, is our largest ring crane. It has previously successfully integrated FPSO modules here in Brazil. The PTC-200DS ring crane is designed for efficient and rapid integration of modules onto an FPSO vessel. Its long reach, compact footprint, and 360-degree rotation capability allow it to pick up and place all modules from a single location on the quayside. Furthermore, its design allows it to be disassembled into parts the size of standard shipping containers, facilitating quick transportation from the USA to Brazil. The operation will be supported by 78 axle lines of self-propelled modular transporters, SPMT, and weighing equipment to accurately determine the weight and center of gravity of each module before lifting. The integration will take place at the Techint Offshore Yard, Unidade Offshore Techint, UOT, in Paranagua, Parana State, Brazil. Boudin added, although Mammoet Brazil and CTTP-76 have only just signed the contract, Mammoet's large fleet and global presence make it possible to start mobilization immediately. We are very pleased with the award of this high-profile contract and look forward to working with the dedicated project team of CTTP-76. The PTC-200DS ring crane is a massive 3,200-ton class crane capable of lifting up to 5,000 tons. It is designed for versatility and efficiency, with a 40% higher maximum load moment than its predecessor, the PTC-140DS. This enhancement allows the PTC-200DS to perform a wider range of lifts and handle more site-wide lifting activities from a single location, which reduces productivity losses due to relocation downtime and minimizes the need for extensive civil works on site. The PTC-200DS is built for strength and durability, capable of withstanding extreme weather conditions, including hurricanes, and operating in temperatures ranging from -40 to 55 degrees Celsius. This resilience makes it suitable for use in some of the most remote and harsh locations in the world. Its high operating speed further enhances its suitability for time-driven projects that require multiple lifts, ensuring that projects can be completed efficiently and on schedule. A recent example of the PTC-200DS's capabilities is its deployment at the Jamnagar refinery in India, the largest refinery in the world, owned and operated by Reliance. Mammoet, the company behind the PTC-200DS, was awarded a contract for critical heavy lift work at the refinery. To prepare for a partial shutdown project, Mammoet upgraded the PTC-200DS to a PTC-210DS, ensuring the crane could handle the lifts as efficiently as possible. This upgrade increased the crane's capacity, enabling it to lift a 2,000-ton structure in one piece instead of multiple sections. This approach significantly speeds up the process, minimizing downtime during turnaround and maintenance work at the refinery. Mammoet's long-standing relationship with Reliance, which began with the construction of the Jamnagar refinery, has continued with recent deployments of 2 PTC cranes at the facility. These cranes have played a crucial role in enhancing project efficiency, allowing for more streamlined operations and reduced project timelines. Cranes are essential in the construction and heavy lifting industries, with various types tailored to specific tasks. Among these, ring cranes stand out due to their unique design and capabilities, particularly in large lifting projects. This detailed comparison will explore the differences between ring cranes and other types of cranes, highlighting the special roles they play, with specific emphasis on their numbers and technical specifications. Overview of crane types. Mobile cranes are versatile cranes mounted on wheeled vehicles, providing mobility and flexibility on construction sites. These cranes include truck-mounted cranes and rough terrain cranes. With a load capacity of up to 1,200 tons and a reach of up to 100 meters, mobile cranes are highly adaptable but limited by their load capacity and reach. They are best suited for short-term projects and tasks requiring quick setup and mobility. Tower cranes are commonly used in urban construction projects due to their high lifting capacity and reach, making them ideal for skyscrapers and other tall structures. These cranes can lift loads up to 20 tons and reach heights of up to 100 meters, with a horizontal reach of up to 70 meters. While they offer significant height and reach advantages, their load capacity is relatively lower, and they require a stable, fixed base, limiting their mobility. Crawler cranes are mounted on tracks, offering stability and heavy lifting capacity, suitable for large-scale infrastructure projects. With a load capacity of up to 3,600 tons and a reach of up to 100 meters, crawler cranes are ideal for heavy lifting and large-scale projects due to their high load capacity and stability.
Little bit to your right. You can see better the right. A little bit to your right.
They can move short distances on tracks, but their mobility is limited compared to wheeled cranes. Ring cranes, distinguished by their circular base and 360-degree rotation capability, are designed for extreme heavy lifting tasks. These cranes, such as the PTC-200DS, are often used in complex industrial projects like oil and gas and large-scale infrastructure developments. With a load capacity of up to 5,000 tons and a reach of over 200 meters, ring cranes are engineered for the most demanding lifting tasks. Their circular base and 360-degree rotation provide unparalleled flexibility in positioning heavy loads, making them indispensable in projects requiring extreme heavy lifting. Special role of ring cranes. Ring cranes excel in load capacity and reach. For instance, the PTC-200DS can lift up to 5,000 tons, more than double the capacity of the largest crawler cranes. This immense load capacity enables them to handle the heaviest industrial components, such as modules for floating production storage and offloading, FPSO, vessels or large infrastructure elements. The ability to rotate 360 degrees is a significant advantage. This feature allows ring cranes to pick up and place loads without the need to reposition the crane, enhancing efficiency and reducing downtime. In comparison, other cranes like tower and mobile cranes have more limited rotation capabilities, often requiring additional maneuvering to achieve the same positioning. Despite their large load capacity, ring cranes have a relatively compact footprint due to their circular base design. This compactness is crucial in confined spaces, such as busy industrial sites or urban construction zones, where space is at a premium. Other cranes, particularly crawler cranes, require more space for setup and operation due to their tracks and counterweights. Ring cranes like the PTC-200DS are designed for easy transportation and assembly. They can be disassembled into parts the size of standard shipping containers, facilitating rapid deployment to various locations. This modular design is a significant advantage over tower cranes, which require more complex and time-consuming assembly processes. Case study: Mammoet's use of the PTC-200DS. Mammoet's use of the PTC-200DS ring crane in integrating modules onto the Petrobras P-76 FPSO vessel exemplifies the crane's unique capabilities. The modules, weighing up to 1,935 tons, require precise handling and placement, tasks well within the PTC-200DS's capabilities. The PTC-200DS's 360-degree rotation allows Mammoet to lift and place all modules from a single location on the quayside, eliminating the need for repositioning and enhancing operational efficiency. This capability significantly reduces project timeframes and costs, providing a competitive advantage in large-scale projects. The ability to transport the PTC-200DS in standard shipping containers means Mammoet can quickly mobilize the crane to various global locations. This versatility is crucial for meeting tight project deadlines and adapting to changing project requirements. Comparisons and limitations. While ring cranes offer unparalleled advantages in load capacity, reach, and operational efficiency, they also have limitations. Their high cost and the complexity of setup and operation mean they are best suited for projects requiring extreme heavy lifting and precision. In contrast, mobile cranes and crawler cranes, with their lower capacities and simpler operations, are more suitable for a broader range of projects, particularly those with less demanding lifting requirements. A floating production, storage, and offloading (FPSO) vessel is a pivotal asset in the offshore oil and gas industry. These vessels are designed to process and store hydrocarbons, oil and gas, extracted from subsea reservoirs. They play a critical role in offshore field development, particularly in deepwater and ultra-deepwater locations where traditional fixed platforms may not be viable. An FPSO vessel is composed of several key components. The hull, often a converted oil tanker or a purpose-built structure, provides buoyancy and storage for the produced oil. The topsides, located on the deck, house the processing facilities that handle the separation, treatment, and stabilization of the extracted fluids. The turret and mooring system, integral to the vessel's design, allow it to rotate freely and maintain position through anchor chains or lines connected to the seabed. This ensures stability even in harsh weather conditions. Additionally, the offloading system, comprising pipelines and pumps, enables the transfer of processed oil to shuttle tankers or directly to onshore facilities via subsea pipelines. The operational process of an FPSO involves several critical steps. First, subsea wells extract hydrocarbons from the reservoir and transport them to the FPSO via flow lines and flexible risers. Once the hydrocarbons reach the FPSO, they undergo separation in the topside processing facilities, where oil, gas, water, and sediment are divided. This separation is essential to ensure that each component can be handled appropriately. Subsequently, the separated oil and gas are processed to meet required specifications, which involves removing impurities, stabilizing the oil, and compressing and treating the gas. Produced water is treated and either re-injected into the reservoir or discharged into the sea, adhering to environmental regulations. After processing, the oil is stored in the FPSO's hull, which can hold substantial quantities of oil, allowing for continuous production even when offloading is not immediately possible. When storage capacity nears its limit or during scheduled times, the FPSO offloads the stored oil to shuttle tankers or via pipelines to shore. Shuttle tankers connect to the FPSO's offloading system using a dynamic positioning system, ensuring safe and efficient transfer. FPSOs offer several advantages. Their flexibility allows them to be redeployed to different locations, making them a versatile solution for various offshore fields. They are cost-efficient as they eliminate the need for extensive subsea infrastructure and fixed platforms, reducing overall development costs. FPSOs are particularly suited for deepwater and ultra-deepwater fields where traditional platforms are impractical. Furthermore, with their large storage capacities, FPSOs can continue production without immediate offloading, ensuring continuous operation. However, operating FPSOs comes with challenges. Harsh weather and sea conditions can impact operations, although modern designs and mooring systems mitigate many of these risks. Ensuring the safety and integrity of the vessel and its crew requires stringent maintenance protocols and safety measures. The entire lift package, consisting of the topside and cradle, is gradually brought to the surface using the VB-10000 lift system. This methodical approach ensures that the topside is safely recovered without compromising its structural integrity. One of the standout features of the Claw is its adaptability to diverse lift projects. The design allows for customization according to the specific requirements of each salvage operation, ensuring quick deployment and efficient recovery. Whether lifting alone or in tandem, the Claw can adjust its operational mode to meet varying challenges underwater. The innovative design and operational efficiency of the Claw were recognized in 2012 when it received the Offshore Technology Conference (OTC) Spotlight on New Technology Award. This accolade underscored the device's significant contribution to advancing safety and effectiveness in underwater salvage operations.